I'm listening to myself. I'm talking to myself.
Yeah, like sometimes people talk just to get it out there, but hopefully we can have a dialogue. So, Jay, 2018, is this fall or spring?
2.
Or what's that? Fall.
Actually, it's
And JO2, yeah?
Yeah.
Someone tell me what the question is.
Determine all positive integers n such that the numbers from 1, 2, all the way up to 2n can be divided into pairs so that the product of sums of the numbers in each pair is a perfect square.
Such that pairs, such that the product, each pair.
The sum of the numbers in each pair.
Oh, the sum. Is the sum?
Yeah, like the sum of the 2 numbers in each pair, and then like multiply all of them.
Yeah.
And the sum.
That has to be a perfect square.
Yeah.
So for example, let's take 1, 2, 3, and 4.
Yeah. That's
You can do
what.
like 2 pairs, right? You can
Yeah,
Then
we just do
we can
2,
put
3, and
2
1,
and
4.
3 together to get 5.
Yeah.
And 1 and 4 together.
And 1 and 4 to get 5.
Yeah.
And then 5
How many times together is a
is
perfect
25.
square?
And 25 is a square.
Yeah,
I
so
think
that
we're
was
standing up now.
Product of sum
For example.
is
Yeah,
perfect
what is
square. Is that right?
Yes.
Yeah.
And it has to be
Yeah.
pairs.
Yeah.
Okay. And how many points does this worth? Just for the 4?
4 points. But what about the senior part? It's also worth 4 points.
Oh, did this make it into the senior one?
It's also
What is it called?
It's question 2 of senior.
Oh.
Same thing. It's also 4 points.
It's also worth 4 points. Yeah.
Yeah. Interesting.
SO2 and JO2.
Yeah.
Okay. So
Why did they make it SO1?
for so each last number in the set equals to 2n. So 4 equals to 2n, and n equals to 2 in this case. 2 is an even number, and like for all n's that are even, it can work because like so let's just say take the case of 1 to 8. Just please correct.
1 to 8.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Not 1, 2, 8.
I'm starting to have second thoughts about being a scribe.
Yeah, okay, can be the scribe.
No.
Okay.
We learned from that. Like,
So this, so you just start from the middle and go outside as well. So it will be, so like you make pairs that sum up to 9. Yeah. So that would be 9 to the power 4, and any power that is even. Like I mean any positive integer to a power that is even will equal a perfect square.
Oh, okay. So basically, if n is even.
Well, like,
Yeah, same.
yeah, that's true.
So if n is even, it works, yeah.
Yeah.
Okay. And the question is, what happens if it's not even? Yeah.
Okay, so let's take the case of 1, 2, 3, 4, 5, 6.
You pass 6 and 3.
So like yeah, if you okay, let's just start from the middle. Let's just do case 1. So, but that will be like 7 cubed, but like a cube cannot be a perfect square if the first number, like that is before the exponent, is not a perfect square. 7 is not a perfect square, so 7 cubed is not a perfect square. It's a perfect cube.
Scribe paper.
Okay, so let's just do the cases one by one. 5 plus 6 is 11. You can't form any other 11s here, so 5 and 6 cannot be in a pair. 4 and 6 is.
Wait, how come we didn't start with 4? Wait, okay.
Can you just give us the perfect square?
But are you claiming this can be done or cannot be done?
Cannot.
Cannot be done.
It can.
Oh, maybe it can.
It can. I should agree.
Wait, then what is?
I was
I have
what
I
is
feel
it?
like
What is it? If you make pairs of 9,
Yeah, I'm like, it probably doesn't work because it doesn't work for
What do you mean?
So
Okay.
have anyone actually solved this problem? But we can solve it together, okay?
yeah,
Yeah.
together.
I actually
Yeah,
saw
like-
question 3 there.
Team live solve. But like, look. So the
live.
question is, does this work? If it does work, it should
It
be
does
very
work.
should be
Yeah.
very easy to
Wait,
show.
Because
Right?
it's easy to show.
How does that
3 and 6
1 and
is
5 and
a
4.
perfect square. Then we are left with 2 pairs, which we can make into 6 times 6, which is 36.
Yeah.
So 36. So a square times a square is also always. A
Yeah,
square.
that's true. That's true.
Yeah.
So it did work for that.
So interesting.
So that works for everything other than one.
Let's see. Oh, that works for everything.
It works for everything.
Oh,
other
what is?
than
How does this work for everything?
It doesn't.
Oh, Ryan, you know what
It
we're
doesn't
talking about?
We just
No, like,
disrupted.
because
We just
after you add
we
two-
didn't create a new theory. We just
You know what the question's asking?
That's
Yeah.
what we did.
and equal or
Oh,
greater
you
than two.
It's about to create a new one.
It's
Oh, wait,
equal
yeah,
greater than two. Or,
maybe it works for all.
Oh wait, no. It's
It doesn't work for
7,
one.
8, 9,
10, and then you just turn it
So far it works for n even and n equals 3, right?
Wait, if we
Next one is n equals 5, yeah?
yeah, n equals 5 is 7, 8, 9, 10.
Yeah, wait.
7, 8, 9,
If-
10, and then
Wait,
you
if
turn it
n
to
equals
Alright, guys,
to
okay,
1.
let's try to not block the view of other people.
Since we already have
Everyone be able to see what's going on.
We have a solution for n equals 3. We can just group these.
I know
Because
what
n equals 3 will take away the
This
odd
is literally, it's this,
number
I know what
of pairs, and so we are left
It's
with
like, it's
an even
literally
number.
that group that's flipped.
Oh.
And then we can pair those together.
Oh, that's an idea. So we have an idea here.
Idea.
So the idea is we have n equals 3
Idea.
here, right?
But we just keep it for all n equals 1.
And we know that n equals 3 has a way of doing it to get a square, right?
So there will be 4 numbers remaining. But like, if it's 4 numbers remaining,
You can use them.
yeah, you can use them
You
because
can
like
pair them.
a plus 9 is 17, and 7 plus 10 is 17, and 17 squared is a perfect square. So 17 squared times 3 squared times 6 squared is a perfect square.
So it's a solved problem.
So it's solved. So every positive
Let's
integer.
figure out how to express this idea in general, yeah? So
Okay.
this obviously works now here because you have 17, 17, right?
Yeah.
Yeah, so 8 plus 9 is 17, yeah?
Yeah. 7 plus
And
10
7 plus 10 is 17, so that's 17 squared.
Yeah. And look,
And here
the
is the square that we did
yeah.
before, yeah?
Square times square is square.
yeah.
Square times square is square. So what would it be in general? It'd be like, so this is important because you're gonna lose a lot. Like when you first do this competition, you're gonna lose basically all your points from not being able to write up your answer. Okay, it's a shame, but that's what happens.
Oh no.
So you can't just like write this and say now you can do it for everything. Read my mind. Yeah, that's not a.
Okay, so like remember from 6 to 10 you add it on 4 numbers. And remember 4 numbers work. So every time you add on 4 new numbers, the 4 new numbers can form a perfect square. And the previous stuff can also form a perfect square. So like it works for all odd numbers except for 1 as well.
Okay, so let's assume we prove it for the even numbers. So for the even numbers, we just pair them up like
Yeah.
the first one with
Yeah.
the last one, second last one with the second
Even
last.
numbers, we can also use this technique where we group them into 4s, and then the 4 we pair
Yeah.
them together.
Yeah. But let's assume n is odd, yeah?
Yeah.
N is odd and it's greater than
2.
let's assume we did it for the special case here.
So greater than or equal to 3.
Okay.
Greater than 3, yeah.
Okay.
Okay, so then we have 1, 2, 3, 4, 5, 6, and then we have 7 all the way up to 2n, right? Yes?
Yeah.
And then we have a square here we can do, yeah? And what's the procedure that we're doing with these numbers to make a square?
So like every 4 numbers you just pair them in and outer.
Yeah.
And like
So every 4 numbers.
Yes.
Yeah.
Yeah.
4 numbers.
Okay, so you have like 7, 8, 9, 10 is one group, yeah?
yeah. And then 11, 12, 13, 14 and etc.
19 plus 15.
or you can
is
just
in a
say
square.
since
The
that's
not
even,
the
every even you can obtain a perfect square, and that's even. It will always.
Yeah, so the outside 2 will always add up to the middle 2, right?
yeah. So also
So I guess you would write
this would
something like-
always work because
Oh my God,
if n is odd, 2n cannot be divisible by 4.
This is like
You'll always fit in one of them.
I plus 1, I plus 2, I plus 3, I plus 4. Or you can maybe write it as like, maybe this could be like I.
Hey, I want to join my hand.
This could be like I plus
You can actually circle
plus 1,
it.
I plus 2, I plus 3.
Nothing has to deserve this.
That's for
Or it could be I minus 1, I plus 1.
You guys just focus on the problem.
Is there anyone watching? I would like to.
Is anyone actually watching?
Also, the seafood pizza I
No.
ordered got contaminated.
Okay. Oh, I wanted.
So why is it?
But anyways, hey, wait. Our voices are being recorded here.
So, I mean, you're gonna have to pick
FBI.
some way to represent this and prove it,
Yeah.
yeah? So maybe you can do like I plus 1, I plus 2, I plus 3, I plus 4, but the numbers are getting maybe too big. I plus 1, I plus 2, I plus 3.
For
At least that won't have
I
any minuses.
Like for all for all I 4i plus 3 4i plus 4 4i plus 5 4i plus 6 you can pair them together.
Well, truly, the way to be truly lazy is because we've already proved that it works for all even end, and that's basically an even end. Since it's odd, you remove either x plus.
Oh, good, yeah, that's good. See, it's not truly lazy. It's relating the previous facts, right? So these all work for even. Well, it's not completely
All
the same.
even
Yeah?
sequences.
Because it's all
So you have to
Well,
generalize it because it doesn't start with 1,
Yeah.
right?
So all even sequences will work because adding from the inside to the outside
Yeah. So whenever there's a
will give the same number an even number of times.
yeah, so whenever there's like a multiple of 4, yeah. So any consecutive string of numbers where there's multiple 4 of them, yeah, should work. Yeah.
Yeah.
But then you might end up proving something like this anyway.
Yeah.
So actually, the probably the best proof is just to do the chunks of 4, isn't it?
Yeah.
Because that's the most direct.
So
And
yeah,
say
for,
everything is related to
because
chunks of
for
4.
even numbers, you start with this group of 4.
So you consider
or
any-
like start with the
I
group
be congruent to 3 mod 4.
Guys, you're still blocking the video.
I would like to take this time to say
Let
all
I be
alpha
congruent to
3,
3 mod
3,
4.
and one
Then for all I
is my friend.
plus I plus 3 is equal to I plus 1 plus I plus 2.
Yeah.
And that is true because it will be equal to 2I plus 3.
Yeah. So the sum of these is always the same as the sum of these, right?
And because they are equal, then when multiplying together, they will form a perfect square.
Yeah. And so when n is even, there's a you can just break them up into chunks like that.
Yeah.
And when
n
it's
is
odd, you just take this one separately.
Yeah.
Yeah. Okay. Excellent.
Yeah.
Well done.
Yeah. So let's solve junior number 3.
Junior number 3.
Okay, can I have
I'll
a
read it out.
solve